Hey everyone, welcome back to the DSA series. Today we will learn about linked lists. So what are linked lists? A linked list is a linear data structure where each element, called a node, contains the data, which is a value, a pointer or a reference to the next node in the sequence. Now guys, each node is connected. You can think of a linked list as a chain or even a train, guys, because each parts of the train is linked to one another. So here's what you need to know, guys. So the first node is called the head. The last node is known as the tail. Unlike arrays, elements in a linked list are not stored in contiguous memory, meaning back to back or behind one another. Here is the node structure of a linked list, guys. So a linked list essentially contains the data, then a pointer to the next value, and it points to the next data, which links to the next value, and so on and so forth. So you guys can see here we have 1 and it's linked to 2, and 2 is linked to 3, and 4 is linked to null. So null is essentially the last item, which means the data has no value. So these arrows, guys, represent the next element or item within our next node within our linked list. Here's a real-world analogy, guys, of a linked list. So a scavenger hunt. You can think of a linked list as a scavenger hunt. So each clue or node gives you the next clue's location, which is the next node. You must follow the chain step by step. You can't skip ahead. Alright, so here are the types of linked lists, guys. You have single linked list, you have double linked list, and you have circular linked list. A single linked list is essentially nodes pointing to the next node only. And a double linked list points to the next node and the previous node. A circular linked list, the last node connects back to the first. So essentially the last node points, or the last node points back to the start of the linked list. So it becomes like a cycle. Here are the key operations. Insertion happens at the beginning, middle, and the end. Deletion, it can happen by the position or value. Traversal, loop through the list, means to loop through the list. Searching or search means we search for a particular value within the list. Here are the time complexities of linked list. So the operation for accessing a linked list, the time complexity is O of n. Insertion at the head of the linked list or the start of the linked list is O of 1, which is constant time. Deletion at the head of the linked list, O of 1 time or constant time. Searching, O of n. Here are some use cases or purposes of linked lists. So a music playlist in which we have the next song, that's a use case. Browser history, implementing queues and stacks, which we'll cover in the next video, guys. So, thank you guys for watching. Um, and in the next video, we will learn about another linear data structure called a stack. So thank you guys for watching, and I'll see you in the next video.